physics, mathematics, and science class. We want to study hydraulic press together. We have learned of pressure, and we learned that pressure is a force per unit area. So pressure is proportional to the force and inversely to the area. Now, how does this pressure help us, or the application of pressure in our daily life? And one typical example is the hydraulic press. How these hydraulic press enable us to lift cars. So some students always face challenge on how to solve the problems or the equations involving in hydraulic press. This one diagram representing how hydraulic press works. Now we are assuming that in the hydraulic press there is an effort which is acting on the master cylinder, and in the master cylinder we have some pistons which is connected to the tube inside the hydraulic press, and it will exert a lot of force within the main master cylinder. So within the main master cylinder too, the force that will exerted on the piston will cause the load here, assuming we have car here. I want to lift this car up. When the force exerts on this cylinder, there is some piston which will cause the fluid to pass through this tube to generate an effort or forces, high force, which will cause this load to be lifted. So, how can I calculate the effort needed here, or the force here, to cause the car to raise up? Now we have seen that there is a force applying to the first cylinder, and this force will cause the fluid to move, which will generate what? A high force, which will cause it to load or to raise up what? The car. So let's see how we can derive an equation of how, or the effort needed for a car to be raised using the hydraulic press. Now, let's assume that within this master cylinder, there is a force, F, here. Then we know that force is also mass times gravity. So we can also represent it as mg. Now, this cylinder, which is a master cylinder here, within the piston we have some distances within the master what? The cylinder. And within the distances we have an area. So there is a distance within this area, and that is what? Our A. Now, after the effort has applied and caused the fluid to push the car up, it will generate an area within this area, which is capital A. Then when it generates an area, there is an effort which is pushing it to cause the car up. So we also have a capital F. And you push it, and let me see whether